I'm presenting our project Explainable Multimodal CNN-RNN for chest X-ray diagnosis. Our domain comes under machine learning. My co-authors are Akash Arvind and Jay Subhas. Our internal guide has been Lavanya Jayaram ma'am. We are grateful for her presence and guiding us throughout this project entirely. From now, I'll tell you what our problem statement is, our approach, and what our results are. Deep learning models for chest X-ray analysis on Mimic CXR, which is a dataset, are powerful but completely opaque. Clinicians cannot understand why a model flags pneumonia or any disease related to chest X-ray, which kills trust and adoption. We have identified two core gaps. One, single modality models ignore complementary radiology report text. And secondly, hybrid model lacks any explainable AI integration. On top of that, regulatory frameworks like GDPR and FDA guidance now actively require explanations for assisted AI assisted medical decisions. Our central research question is that can a transfer learning enabled CNN RNN framework with integrated explainable AI bridge gaps in transparency and trustworthiness on Mimic CXR? We address this with four components: CNN for image features, RNN for report sequence, multimodal fusion, and unified explainable AI with GradCam and Shape algorithm. This we will address by solving the black box problem, the black box opacity exactly, from the multimodal fusion. We are proposing a multimodal CNN-RNN framework that jointly analyzes chest X-ray images freely with radiology reports as free text inputs. The dataset is a 3 lakh image report pair example for multi-label data disease classification. We integrate GradCam for visual attention heat maps and Shape for future attribution on the text side. The result is a highly diagnostic, accurate, and quantifiable interpretability involved, which is also has reduced cost through transfer learning, which overall improves the medical AI systems that we currently possess. For the literary review, we have explored four papers. One includes ACM XAI review paper also, and others are healthcare perspectives also. So the consistent finding across all four is that interpretability is essential but rarely implemented in hybrid models. The key gap we filled is that no prior work applies CNN RNN hybrids with unified XAI to mimic CXR multimodal data. Our work will extend the 2025's data sets, which we have currently, while implementing transfer learning on it for radiology efficiency and speed. We found out there are multiple issues and challenges on the way. First, opacity. CNN and RNN give no insight into decision logic, creating risk of hidden biases and clinical rejection. Secondly, multimodal fusion is architecturally hard, given a 3 lakh image report pair with imbalanced and noised. Third, XAI coherence. Most XAI methods are modality specific, and getting a unified cross modal explanation is an open problem that is being currently addressed. Fourth, the compute. To address this problem, we have implemented transfer learning so that it can be used anywhere across any constraints. Our proposed work is a specific pipeline which involves image input and text input, which will pre-process it and extract the given features, combine it and given prediction, which will have an XA or the explainable AI layer over it, which then we will evaluate based on faithfulness, interpretability, and accuracy. The CNN branch is fine-tuned as by RESTnet model, and for RNN, which is a text input, is being used for LSTM. So combined with these, are we combine this with an attention layer, which will get you an explainable AI layer over this, which will give you a proper evaluated output for you. As I mentioned before, the input will be both radiology reports, which is free from text, and images, which can be chest X-rays. So when we run through the pre-processing with respective features, and then run it through the transfer learning, which is RNN and CNN for the image and text part respectively. So this is then run into a very simple explainable AI module, which is Shape and Lime for text attribution and GradCam for image attribution. So unified, you will have one singular output, which I'll show you now. Then it will visually explain why this decision was made by the model, so that there is more accountability and more explainability and the removals of black box overall, so that we have better outputs which can be trusted. The system requirements and tools are almost similar to any other project that involves explainable AI and medical datasets. For this case, we are using PyTorch and datasets from Hugging Face with GradCam and Shape. Everything will come under the Python package, which we are training over, or it can be trained over a GPU, which is NVIDIA's RTX models. Module 1 handles data pre-processing, aligning image report pairs and handling class imbalance. Module 2 is a CNN feature extraction using transfer learning for spatial representation. Module 3 is an RNN sequential processing with LSTM on the radiology text. Module 4 is an attention based fusion and prediction layer. Module 5 and 6 are explainable layer scoring and evaluation layers, respectively. What we have here is the output of a pneumonia's chest X-ray report. Here we are showing the image output of the model. So the left side is the raw image that will give us input. The right side has an explainable layer over it. So in every single place you can see a heat map. Heat map is generally the more darker or more intense the concentration of a grad canvas, there is the more amount of input on it. So, as in, here is where the pneumonia is in each of the cases. So, as you can see, there are concentration of reds everywhere. Reds mean that there is pneumonia for the patient and it must be addressed accordingly. This is how the image layers, CNN outputs, explainable AI works. Next, we have here is the text layers output. When we give them a freeform text, we do both cosine similarity, which will get you the most important words that are being regularly used. In this case, we can see for cosine similarity on the left, it is pneumonia, which is over 80%. And this text input also has an explainable layer over it, which is shape. So these two will be combined. On the right side, you can see that the patient has a fever of 38.9 degrees Celsius. This is one of the core reasons, along with that she is 67 years old and has mellitus and hypertension. Combine this is the output that we are getting for the text. This is our most important layer we have. We combine both the image and text feature as one. So from this image output of the analysis, we can see which has more contribution, the text, which is the radiology report, or the image, which is just X-ray diagnosis report. So from this, we are able to get why this is happening in what way and what and how explainable AI works is the core idea behind our project. Our project talks about how we can use explainable AI to make current clinical systems better rather than talking about accuracy where there are millions of paper on it. We take a problem that is less addressed and it is needed by more of the people. Next, we have our references. Our base paper involved enhancing chest X-ray diagnosis with multimodal deep learning network. So this is basically the base paper which we worked on. They spoke about combining the image and text input. We use that and added an explainable AI over it, which is the game changer for us. I thank you for the time you have given for me, and I am open to any questions. You can contact me through my mail ID. Thank you.